Hi everyone, Adarsh here from Adarsh Model Train. So this is a continuation series where we will configure servo turnout, snap turnout, then we will configure two LED signal, three LED signal lights together into the single node using REST API. So let's get started. We'll go into github.com/adarsh-model-trains. Said that we'll go to Jmri Mqtt Spring Transformer wireless ecosystem. Then we will get into the Spring ESP Arduino solutions, and inside that we will go to REST servo snap turnout signals. Once we go into that, we can see here we have Arduino code, ESP code, and servo calibration sketch. We'll just download the source code here. We'll just download on the desktop. Source code got downloaded. We'll extract it. So first we will upload the code to the Arduino. Here you can see here we have to go to config.h. We will just say one servo turnout board, one snap turnout board, one light board. Total number of boards should be 3 boards. We are configuring signal type anode false, slow moving. We'll just make it false so it will be easy for us to understand there. This range we can give 1100 to 1800. But actually we have to get this value from servo calibration sketch. So if you are following this video tutorial from the start, you know how to get that. So here already we have Arduino Uno as well as ESP8266. Let's upload the code first to the Arduino Uno. So connect it to this. We already downloaded the source code. So let's go to tool. First select the Arduino Uno and port we have to select. Everything is good. Just want to make sure. Yep. Let's upload the code. First compile the code. It's compiled. Let's upload it. It will take very less time because in Uno it will take very less time. Code is uploaded. Here in the serial monitor we can see total number of PC96 board for turnout signal is 3. Board number 40, board number 41, board number 42 for the servo turnout, snap turnout, and light and signal here. So 3 board we have configured. Every information will be there. So let's close this. Let's go into ESP. Let's open the ESP code. Go to config.h. Let's check the username password for wireless. This is the IP address for the machine where our application is running, and this is the port number, node ID. This is the endpoint. So everything looks good. Let's remove this and connect the ESP. Connected the ESP. Let's go to tool, board, ESP port. Let's select the node MCU 1.0. Go to port, select the port here. Compile the code. It will take time. I don't know why there is so much time for compilation for node MCU always, and for uploading also it takes time as compared to Uno or Mega. Even Nano also take less time as compared to node MCU. Let's see. So we have compiled the code. Let's upload the code. So it should be able to connect to the Wi-Fi, but it should not able to connect to the server because we haven't started the server yet. Let's see, uploading 15%. it's uploaded. Now let's see here. So connected to the Wi-Fi but not able to connect to the server. It should say after some time, yeah, error to reaching server, because we have not started the server, but that's fine. So we are good with this. So in the next section what we'll do, we'll just configure all the PC96 board as well as all node things together, and then I'll explain, and then we'll just take it further from there. So now we have done all the configuration. Here you can see, here we have our ESP8266 which is connected to node Arduino Uno here, using this as white and black, which is TX and RX pin. We have this red wire which carry 3.3 volt from Uno to node MCU, and there's a one brown wire here back down. This brown wire is carrying ground to the node MCU from ESP. Here you can see there are a bunch of PC96 board connected in the series in the chain. So here you can see there's a brown and red wire which is taking 5 volt from Uno to the first board of PC9685 board, and here yellow and orange which carries SDA and SCL line from Uno to first board of PC96 board. And here you can see this is a board number 40, address 40, 41, 42, as we have seen earlier. Here you can see there is a external 5 volt power supply coming to this breadboard here. So from this breadboard we are just taking it from this side to this side from these two white wires, and then every board is taking GND as well as 5 volt here from this side of the breadboard. Here blue one carries GND and white is carrying 5 volt. Here same here, 5 GND and 5 volt here from this. And then you can see all the boards are connected in the series by these connectors. And let's go to the configuration one by one. First let's start the MQTT and Spring Transformer application, and then we will validate our configuration. So for that what we have to do is we have to just go to the desktop, config. This is our configuration. This is our MQTT started. Let's go to the Spring Transformer application folder. Here we'll just validate our configuration. Open the configuration into YAML file. Here you can see for node number 1, in node is enabled publishing to MQTT. REST API is also enabled here. You can see we need one light, two LED signal 1 only, 3 LED signal 1, servo turnout we need only one, snap turnout 1. Total number of turnout board is 2 because 1. So basically snap turnout work on different PWM frequency and servo turnout works on two different on the different PWM frequency. That's why we need 2 turnout board. But light signals, 2 LED signal, 3 LED signal, and light works on same PWM frequency, so we can manage with the one board. And this is the topic where our application gonna publish the data after transforming, but here we are using REST API, so we are not worried about that. Let's close this and let's open one more tab here. cd spring, and we have to start the transformer application, so we have to go into I'll just go into main here, go to Spring Transformer application here. Here you can download the jar file, you can download the configuration file, everything I have explained earlier. You can just copy this file here, or copy this command here, and then we can just directly execute the command. So the moment we execute, where we can see the server folder has been created, and application started on port number 8090. So what we will do, we'll just validate our configuration first. So what we will do, we'll go into this readme page little below. We can see the endpoint here. So with this endpoint we can get information of all the nodes which are configured on the system basically and everything, but I'm more interested into node 1. So what I'll do, I'll just make /1 node identifier, and I'll get the information only for node 1. So node 1 is enabled here, publishing is enabled, REST API is enabled, light starting address 10,000, 1 light, 2 LED signal 20,000 starting from 20,000, 1, 3 LED signal starting from 30,000, only 1 we need. Servo turnout, Jmri address 40,000, we need only 1. Snap turnout starts from 50,000 in Jmri, we need only 1. Total number of turnout board we need 2. Light board we need 1. Here it will tell total number of pins. Light pin required 1. Total number of signal pin required 2, because 2 LED signal. 3 LED signal required 3 pins only. Servo turnout required only 1 pin. Snap turnout required 2 pin on the board. It will say board required. Servo turnout board required is 1. Total number of snap turnout board required is 1, and light and signal required board is 1. If we come a little bit further here, you can see servo configuration 40,001 on Jmri. Board number 0, pin number 0, throw signal, board number 0, pin number 0, close signal. So if we see here, this is a board number 0, pin number 0. We have configured the servo here. This is a servo machine. So let's go back. Snap turnout, Jmri address 50,000, board number 1, pin number 0, it will send a throw signal. Board number 1, pin number 1, it will send a close signal. So let's go to here. This is a board number 0, board number 1, pin number 0 and 1, taking to this relay switch to control the throw and close position for this snap turnout. So here you can see this relay switch is taking signals from board number 1, and it taking from this blue wire, and from this brown wire it's taking 5 volt from this breadboard and taking it to this relay switch. And this relay switch has, if you see here, there's an external 12 volt power supply coming to this breadboard. From this breadboard it's taking, these two wires are taking this 12 volt to the central pin of the relay switch, which is a common one. And if you see, there are 2 LEDs connected here. So let me clarify this. Here you can see there is a gray wire and white wire which carries signal here for this LED and this LED. So the LED which is continuously glowing, you should never put your snap turnout towards that side. Always put which is in the close position here. So here if you see one wire for the snap turnout is here, and for the another one, if you see, these black and white is taking for this blue and this blue. So there is another blue light which is close. You should put another wire here, and then common you can take it from anywhere from this 12 volt. So we will go through that once again once we just do the testing, but this is how we can save our turnout from burning. Then once we go into this was the snap turnout. If you see the light 10,001, board number 2, pin number 0, on and off. So if we go into this, board number 2, pin number 0, here this is the relay switch for on and off for the light here. So this orange wire is carrying signal to this relay switch, and here you can see this red and brown wire is taking power supply for this relay switch for controlling this. And you can just connect the from the middle one, and from this one you can connect your lights. Then we'll go to 2 LED signal. Here you can see Jmri address 20,001, 20,002, board number 2, pin number 1, and board number 2, pin number 2. So for red and green. So if you see here are two, if you see in the two LEDs are configured here, red and green, which carries yellow for red and green for green. And if you see it, it's configured on pin number 1 and 2 here, as it was suggested here in the configuration. And if we see go to the 3 LED signal here, 30,001, 30,002, 30,003, board number 2, pin number 3, 4, 5. So let's go again. Board number, this is a board number 2, 0, 1, 2, pin number 3, 4, 5. So pin number 3, 4 and 5 here, and these are the red, yellow, green. So these are the configurations how we have done. So now in the next step what we will do, we will start the Jmri and we will start testing everything, and then we'll take it further from there. So let's open the Panel Pro and then go to Tool Table Turnouts here, and let's see here. First what we have to do is here, first we have to see 40,001 for servo turnout. So we have 40,001 servo turnout, and it will be this one. So I'll just make it closer here. So I have not stick it to anything, and we have not got the calibrations and all. We have just assumed, and we have just for the demo purpose, but you can get that calibration number and fix the turnout properly and then do it. So here, that's why it is pulling up the whole turnout rather than if I just make it steady here. So, and actually it should be connected here. This be connected to this section here, then it should work properly like this. But just for the demo purpose this is. So servo turnout is working. Let's go to Snap Turnout here. So our Snap Turnout, if you see here, Snap Turnout here, it will be this guy here. So you can see light will go there and come back here, and light will come here and do the, I'll just show you in more, and this is the so here you can see first intro, red will go here and then come back, and this will work. And if you see in the close, blue will go there and come back here. So that's the reason I was telling you to keep the connection to that side where light is not on, because if it's continuously powered from, if you by mistake if you configure here, it will burn immediately this turnout, because this motor here. So it's the concept is that it will give that much electricity so that it will move and it will come back. So what it will do, it will enable it and for some millisecond and come back here. It will enable this and go back there. So that's the concept for relay switches for Snap Turnout. So this is how the turnout works. Let's go to the light here. For the light, if you see, we have address 10,001. So we have 10,001 here, and this should be this guy. So you can see the green light is gone. So here you can see, we'll go to lights here. It's off now. Let's see here, green light should come on, and once we say off, green light should go. So this is how the light should work. And once we go into signal head here, So we have two LED signal on 20,001 and 20,002. So we have two LED signal here. We'll say dark. We'll make it. We'll glow the red one. No, actually this should be this 2.1 should be the 2.1 should be the. So here if I just glow this, so this red should work. So this red is working. If I just make it green, green should work. So green is working here. I'll just show it from the closer look. So red is working, then green is working, and if I just make it yellow, it will glow both the lights because it assumes that I am using RGB pin. So for RGB pin, if you just glow red and green, it will make it yellow. So I'll just close this one. So both of them are closed. Now we'll go to 3 LED signal. 3 LED signal is 30,001, 30,002, 30,003. 3 LED signal. So let's see 3 LED signal here we have. So let's make it red. So red is on. Let's make it yellow. Yellow is on now, and let's make it green. Green is on. Let's go to the closer look here. Red, yellow, and green. So this is how we can just configure everything together, like Servo Turnout, Snap Turnout, and light, 2 LED, 3 LED, everything together in the single node. So now I have configured only 3 board. Every board you have 16 pin. For servo only 1 pin is required. So every board you can configure 16 servo. For 2 LEDs, for snap turnout you need 2 pins. So every board you can configure only 8 snap turnout. And for lights only need 1 pin. So in the one board you can configure 16 lights. For 2 LED signal you need 2 pins. So in one board you can configure 8 2 LED signal. And for 3 LED signal you require 3 pins. So for 3 pins in one board you can configure 5 3 LED signals together. So you can make the chain of these boards up to 64 board. And I have tested 12 nodes in this system and it works fine. So, and in one node you can configure 64 boards together, and 64 boards will have almost like 1080 pins, I guess. That's what, if my calculation is not wrong. So that much pins you will get, and you can do all the configuration easily. So I guess this is done for today. We'll take it to the next. Just stay tuned for the next video. If you like it, please subscribe to my channel, so I'll get motivation for doing more innovative things for model layouts. Thank you.